So what happens if it's not neutral? Well, that's where the pH scale comes in. The pH scale looks at the concentration of those hydrogen ions, and it's going to look at the power or the activity of those hydrogen ions and what they can do. So it's a way of describing those hydrogen ions and their concentration. Now, the formula looks tricky, right? pH is equal to the negative log of the concentration of hydronium. Notice these brackets here. The brackets are a way of writing concentration. So anytime that we want to talk about concentration, anytime we want to talk about the concentration of something, instead of writing out the word concentration, we can just put brackets around it. So negative log of the concentration of hydrogen ions. Well, again, that looks tricky, and we know that we're not allowed to use calculators in class. So how are we going to calculate this? It turns out that every formula for concentration that we will get, so for instance, concentration of hydrogen ions, will follow this format: 1.00 times 10 to the negative n. What does that mean? Well, that means that it's a very small number, first of all, because it's a negative exponent, right? So this would be, if we were to put it into normal non-scientific notation, it would be 0.000, however many zeros we need to get to this n value. So n can be any whole number. So 1, 2, 3, 4, and so on. Okay? So if that's the concentration, and our concentrations are always going to look like this, if we plug that in there for the concentration of hydrogen ions, it turns out that your pH is simply just going to be n. So in other words, we look at the n value here, whatever number it is, 1, 2, 3, 4, 5, 6, 7, 8, 9, whatever it is, and we just simply make it positive, and that's our pH value. So for example, if I tell you that the hydrogen ion concentration is equal to 1.00 times 10 to the negative 4, well, that means the pH equals 4. Okay, and then if I tell you that the concentration is equal to 1.00 times 10 to the negative 12th, well, that means that the pH is equal to 12. So pretty easy as far as calculations go. Definitely not one of our tougher calculations. But it does turn out that the pH scale is a way of determining the effect of those different amounts of hydronium or hydrogen ions. Okay, so on your paper, you have a line that goes horizontally across your paper, kind of like so. Over here it says 0, over here it says 7, and over here it says 14. So what I'd like you to do right now is label the regions. So if it's 0 to 7, meaning less than 7 down to 0, we call that an acid. And if it's from 7 to 14, we call that a base. We really want to get tricky. Don't forget, bases are also known as alkaline, like alkaline earth. They're known as alkaline solutions. Okay, and then what I'd also like you to do is mark the middle as neutral, and then finish up by marking some examples of substances that are acidic or basic or neutral. So for instance, neutral, you could put distilled water. Okay, for bases, you could do things like, for instance, 13 is bleach. Okay, for an acid, you could do something like, let's see, this would be 3 OJ, orange juice. Okay, so go ahead and put a few of these in here so you have some good examples, things like soapy water or lemon juice, or you could do pee, I guess, urine. But put some samples on there so that way, or examples, that way you can go back to this, and if you need an example of something that's acidic or basic, you have a nice pH scale in your notes.